Let's go back to sine x over x. So remember its graph. Looks something like that. And there's a couple things that I could do to define this at the point x equals 0. One thing I could do is I could fill in the hole. What I mean by that, I could define a new function that's equal to sine x over x whenever x is not equal to 0. But when x is equal to 0, I could just define it to be equal to 1. And we'll bring in a little color, and I can fill in this graph by just plugging it in. Or I could make a new function h of x, which is my original sine x over x, but it's not defined at 0. And then I could give it a different value. I could define it to be equal to 0 when x is equal to 0. And here I'll plug that in. So the graph of h of x, it's the white part, and then it becomes the yellow point. The graph of g of x, you see that it's the white part, and then that one hole is filled in. And the difference here is that one of these functions is continuous at x equals 0, and the other one is not. So the one that's continuous, it's going to be the function where the limit of the function as x goes to 0 is equal to the value of the function. And we already figured out that the limit as x goes to 0 of sine x over x is equal to 1. And that's going to be my g of 0. So this function is continuous. But this one is not, because the limit as h of x, that's sine x over x, goes to 0, that's not equal to h of 0. That's not equal to 0.